Yes, Yellowstone is a volcano. My name is Jake Lowenstern, and I work for the U.S. Geological Survey. I'm the scientist in charge of the Yellowstone Volcano Observatory, and that's a partnership with the USGS, the University of Utah, who does the actual monitoring of the earthquakes and ground movement, and the land manager, Yellowstone National Park. We're looking here at a geologic map of Yellowstone National Park, and the different colors represent different geologic units, different rock types, different ages of rocks. You can see that all of the pink units in here, these represent the very youngest lava flows, mostly, that erupted at the Yellowstone volcano. Most of these are between about 160 and 70,000 years old, and we see that they're covering up this area of the park. It turns out this is the Yellowstone Caldera. It starts around here and it moves out into the area over here, and it's about 50 miles long. And it formed when this green material erupted. This is called the Lava Creek Tuff, and the age of this unit, it's found here in the light green and the dark green, also to the south, the age is 640,000 years. This was an enormous eruption, and it spread ash over much of the United States, and a similar eruption to that today would certainly be a big deal. But since this time, there have been about 80 different eruptions at Yellowstone. Some of them are very big. This one is the most recent. It's 70,000 years old, and it's called the Pitchstone Plateau lava flow. In fact, the size of it is about the size of Washington, D.C., and it's about 100 yards thick in most places. So this is what we're looking at. We can see volcanic rocks everywhere, evidence that this is a really unusual place. It's a massive volcano. Some of the eruptions from Yellowstone are truly enormous eruptions, some of the largest ones that are known of on Earth. And that includes this green unit here, the Lava Creek Tuff, as well as the purple unit, which is the Huckleberry Ridge Tuff, which is erupted 2.1 million years ago. So these are some of the largest eruptions that we know of on Earth, and because they erupted so much material, on the order of 1,000 cubic kilometers or 250 cubic miles, then they get termed as super eruptions, really big eruptions. And the way that it works, this is kind of new terminology, and super eruptions, if you're a volcano that has exploded and created one of these deposits, then you get called a supervolcano. And that's where the word supervolcano comes from. So you have this magma that's beneath the surface, and when it erupts and comes out, there's no longer support for the ground surface up here. And as a result, the ground surface just caves in, it founders and it falls in. You're left with what's called a caldera. It's a subsidence or a feature, or a cave-in feature that's caused when it loses its support of the underground magma. As a result, when it first formed, you had a hole that was on the order of 50 miles long and maybe even 1,000 or 2,000 or 3,000 feet deep in places. We have this deep magma chamber, and there's a lot of heat. The magma is generally at temperatures like 800 degrees centigrade, or something like 1,300 degrees Fahrenheit. There's a lot of heat. That heat heats up the rock, and that rock then, there's conductive cooling, there's water down there, that water gets heated up, and so much of the water that's near the surface at Yellowstone is actually at boiling temperature, and as you go down, it gets hotter and hotter. So that's creates a pressurized system of a boiling aquifer, of boiling groundwater, and that becomes unstable. It can cause earthquakes, and of course it causes the thermal features that we see everywhere at Yellowstone that make Yellowstone so famous. The geysers, the fumaroles or steam vents, the hot springs that are so beautiful and contain so many different kinds of life and thermophile bacteria. So that's what makes Yellowstone special, and it's pretty much all due to this underground magma system. So we have these massive eruptions that are really quite rare, and then we have these lava flows that happen more frequently, but still not. The last one was 70,000 years ago. But this would be a really big event if it happened again within the park. It might cause forest fires, it might dam up rivers, and it would cause a lot of commotion and anxiety within Yellowstone, but it would have very little long range effect. It wouldn't affect people in states that are hundreds of miles away, certainly. We have other big events that occur at Yellowstone. For example, earthquakes. In 1959, there was a magnitude 7.5 that occurred out near Hebgen Lake, caused a lot of damage in the park, and also caused a lot of changes to the thermal areas within Yellowstone. The Teton Fault is on the border of the Teton Mountains south of the park, and it potentially could have a very big earthquake associated with it. Beyond that, we have the hydrothermal explosions, or steam explosions, when the groundwater system becomes too pressurized and erupts during some sort of perhaps an earthquake or due to a change in lake level. And what happens is you get the groundwater system can form really large holes in the ground, sometimes hundreds of feet across. This is a turbid lake right here, Indian Pond, and Mary Bay. All of these were created in the last 15,000 years by explosions of the hydrothermal system. In this case, no magma is erupted, and they're fairly localized events in terms of their damage, but they're still definitely relevant for what's going on at Yellowstone and need to be watched. Almost every year, somewhere in Yellowstone, there is a small hydrothermal explosion. Sometimes they might only be a couple feet across, but we find evidence for them. Sometimes we see a little bit of smoke coming out or fumes coming out in a place we didn't expect it. Sometimes somebody hears it. And in lucky cases, we actually get to witness one of these explosions, and that's happened every few years as well. We have no way of predicting these explosions, especially the smaller ones, but we hope that as time goes by, we'll get more and more knowledge about how they work, and maybe get the chance that someday we'll be able to be able to have some predictive capabilities for these explosions.